So you have next to the unit circles, that little table set up there. We are graphing the sign. So which coordinate are we looking at? As we go around our unit circle, we will be looking at what? So go ahead and fill in your chart with the corresponding Y values. And in the other class, one of the kids said, oh, this is so boring. I get it, do it anyway. We have to be so comfortable with our unit circle that we can just rattle this stuff off without even looking at the circle. What is the biggest Y value you're coming up with? As you fill in your table there, what is the biggest Y value you're getting? 1. So I am going to make my Y-axis, and the smallest one is -1. So I'm going to make my Y-axis just labeled 1 to -1. And then my X-axis, I have used the unreduced. He's got them reduced here, and that's fine, but I wanted you to see they're in increments of pi/6, 30 degrees, right? All right, so let's start plotting. At pi/6, what was the Y value you took off the unit circle? 1/2? It's not part of it. Oh, what was it at 0? Is 0 in there? No. What is the Y value at 0? 0. So I'll start with that one. And there's pi/6. What was 2 pi/6? Or pi/2? √3/2, which is bigger than 1/2. All right, and then pi/6, that was 1. So far, I'm getting something that looks like this when I connect my dots. Okay, and then they start back down, right? √2, 1/2, and 0 again. And then what happens at 7 pi/6? Now it's negative. Bottoms out at -1. And then it starts back up again. And then by the time we get back to 2 pi, we're right back at 0. And what do you think would happen? He stops. It's logical to stop. But what do you think would happen if we kept going? It would just repeat itself, right? Because the period is pi, once around the circle. So that, my friends, is your sine function. That's your sine curve. Nice little hill, nice little valley. The midline, that's right here, for this guy, the midline is 0. But for some of the pictures we looked at before, the midline is other places, right? But this time the midline is 0. The period is 2 pi, right off the unit circle once around. The amplitude, the height of the sine curve is 1. We can change that. We've seen it happen in some of our other pictures. But for the standard sine function, the amplitude is 1. And the frequency is the reciprocal of the period, so it would be 1/2 pi, right? All right. Now, the next page, he has you do exactly the same thing with the cosine function. So would you do that on your own? Fill in your chart, this time using the x values of your ordered figures, cosine, and then plot that. shifted a little bit, and that makes sense. It couldn't be exactly the same because the coordinates are different. But does it make sense to you that the shapes are so similar? Think about the numbers that you're plotting. Aren't you plotting all 1/2s and 3/2s and 1s and 0s? Sure. So it's just shifted over a little bit. And because of that, doesn't the cosine have exactly the same characteristics as the sine? Amplitude is 1, period's 2 pi, midline is 0, and the frequency is 1/2 pi. Does that make sense to you? Absolutely. Things that look like this are called sinusoidal, and people hear that word and they think you have to be a sine to be sinusoidal, but you don't, because a cosine is exactly the same as a shifted sine curve, right? So anything with this kind of repeated hill and valley, whether it's a sine or a cosine, is called a sinusoidal curve. Okay? All right. Any questions about that? All right, let's look at example 1. 2 periods of the sinusoidal function are shown in the figure above. So 2 periods are shown. I think you could figure that out on your own even if you didn't tell you. What is the period of this particular curve? Pi? Pi? We're looking at example 1. We got one hill and one valley. And we have another hill and a valley. So one hill and one valley is pi. What is the frequency then? If the period is pi, the frequency would be 1/pi. What is the midline this time? This guy's been shifted up. The midline this time is 3. Would you agree with that? 3. And the amplitude, now be careful, what's the amplitude? 3. Because isn't the hill 3 high? And that's the amplitude. Amplitude, how far above the midline do you go? How far above the midline do you go? All right, example 2. Several periods are shown. See if you can write it for example 2, see if you can determine period, frequency, midline, and amplitude for that picture. Anybody figure out the period? What's the period, Charlie? Pi/2. And I don't know how you figured that out, but if you, a sinusoid is going to have hills and valleys, right? So from top of the hill to top of the hill is a period. Or one hill and one valley is a period. However you think about it. So he is right, pi/2. The period of this thing is pi/2. If you can draw pi/2, then everything else you draw is a repeat of that. Frequency then would be 2/pi. What's your midline this time? 1. Your midline is up at y equals 1. Everybody good with that? And your amplitude is 2. Perfect. Perfect. Don't But isn't it always gonna be the midpoint of the top and the bottom? The midline? So if push comes to shove, you can just average the top and the bottom and find that. All right, example 3. We have a sinusoidal function that has a maximum at the point pi 8. So here's pi, here's 8. That's the maximum. Okay, now that means it's the top of the hill. Here would be the bottom of the valley. And here would be another top of the hill. Would you agree with that? Okay. The first minimum after reaching the maximum occurs at the point. So this is the first minimum after the maximum. So here's my maximum at pi 8. The first minimum is at 3 pi negative 2. Obviously my scale is Walker Jaw, but there it is. Okay. Find the period, frequency, amplitude, and midline for this graph. Who has a thought? Charlie?
Well, if the height of the hill is pi, and the bottom of the valley is 3 pi, then that means that 3 pi is in the middle, so that means that the other peak is 5 pi, which means that the period would be 4 pi.
Bingo. I couldn't say that any better, Charlie. That's exactly right. That is exactly right. Now we're going in a circle.
I figured it out.
Okay. All right. So, period from hill to valley is going to be half of the curve. Would you agree with that? And he said half is from pi to 3 pi. That's 2 pi. So the whole period must be 4 pi, which means the frequency is 1 over 4 pi. I'm going to write that carefully. 1 over 4 pi. All right. Good. How about amplitude and midline? Midline is 3, Parker says, because the midline is going to be halfway in between the top and the bottom. I'm sure it does not make sense that way, but it's halfway in between. So if the top is at 8 and the bottom is at -2, the average of those, 8 plus -2 divided by 2, is 3. You're exactly right. And if the midline is 3, then the amplitude is 5. Beautiful, beautiful, beautiful. All right, let's see what's next. Uh-oh, we've seen this before. And in fact, we have seen this exact problem before. This is the problem that has the clock that doesn't work. You remember? All right, so let's see if we can do this. So start writing down some points. Again at 30 minutes, right? So halfway in between, which would be 15, The hand is straight down, which would be how high? Under 12? Are they okay with that? And then halfway in between that, the hand is sticking straight out. Oops. So it would be how high above the ground? Sticking straight out? Under 20. And again at, what's this one, 22.5? How do those points look to everybody? Now, you know we've done enough of these crazy problems to know that sometimes we can use those points and sometimes we'll need to add on. But I think this time we're in luck because isn't this a high point? So I can call this one 0 and 28. So I can use my points. Would you agree with that? What is the period of this thing? 30, absolutely. The period is 30. And that means the frequency is 130, 1 over 30. So the period is 30 minutes. The frequency is 1 over 30 minutes, a 30th minutes. What's the amplitude of our curve? 8. Why is the amplitude 8? The clock hand. Because the clock hand, the radius of the circle that that hand follows is 8. Why is the amplitude of the regular sine curve 1? Because the radius of the unit circle is 1. This radius is bigger. What's our midline? Midline is 120. Are you okay? Center of the circle. Find two intervals for which the graph is decreasing and concave up. Decreasing and concave up. Do you see one in the picture? Right here. So we'll express that as an interval. That's 7.5 to 15. Intervals are x-act or x-coordinates. Now there'll be another one over here, right guys? Would there be another one right here? So I can go through and like find this point, find that point, or I can use my common sense. Isn't this one period later? And since the period is 30, won't that one be the interval from 37.5 to 45? Because it's going exactly one period later. Going now to page 4. Almost out of time. Explain why the range of the sine and the cosine is -1. You graphed them. I graphed them up there again for you. They're graphed. Why is the range -1, 1? Because where are these points coming from? The unit circle. Right? They're coming from a circle. It's a circular function. Even if the radius of the circle were bigger, remember that cosine is x over r, so it's always going to reduce to a number less than 1. Cosine must be less than 1. Sine must be less than 1. Go back to geometry whenever you learn SOHCAHTOA. Cosine is adjacent over hypotenuse. Won't that be less than 1? Yes, because the hypotenuse is the biggest. Yeah. So why is the range? Because cosine and sine are always less than 1. Period. They come off the unit circle. The ratio of adjacent to hypotenuse is going to be less than 1. How many full cycles of the sine can be graphed on the interval from -2 pi to 4 pi? 3. That's 3, a distance of 6 pi, and that's 3 periods, 3 2 pi. Is cosine even, odd, or neither? That's a good review question. What's it mean to be even? plug in a negative, it doesn't matter. So if it's even, the cosine of negative pi over 3 will be the same as the cosine of pi over 3. For example, that's what it means to be even. Is that true or false? Right? Here's pi over 3, right? Here's negative pi over 3. Tell me about x. Stays the same. Stays the same. So does this negative matter? No, it's even. Cosine is even. Also, if you look at my cosine picture up there, does it have symmetry across the y-axis? Even functions have symmetry across the y-axis and cosine does. So a couple different reasons for that. All right, friends. I'll see you tomorrow, huh? More fun and excitement. Oh, wait, stop. Hang on, wait, yes, I have directions. Wait. I gotta see. I think we leave everything here.